Hi guys, welcome once again, right? Yeah. So, in the previous of our class, we have seen or we have known something about the geography. So, the class was called as the introduction to the geography, and we have seen how the geography has evolved from just the descriptory science to an analytical science. Okay, and we have also seen what is the difference between the natural geography and the human geography. Okay guys, yeah. So today we will be talking about the universe. Why, what is necessary for us to talk about the universe? It is because we should know, right, we should know where our earth is present within the universe. Okay guys, so what exactly is the universe, right, and who gave the term universe? Okay, so the universe is the totality of the matter is known as the universe, and the totality of the matter includes all the space, all the contents and all the times guys. So totality of the spaces, matters and contents, when they are put together, that is called as the universe. Okay, and the term universe was coined by Hubble. Okay, Hubble in 1926. So guys, till 1926, the Westerners were not having a term to describe the totality guys. So in 1926, Hubble gave the term universe. And you know, we, the Indians, as I told you yesterday's class, in the yesterday's class, right, the ancient texts of the India, they talked about the Brahmanda, that is the universe guys, right, and that was long back around 6 to 7k BC, 6000 to 7000 before the Christ. We are talking about the term Brahmanda, right, and as the name says, Brahmanda means a big egg guys, right, and even the NASA has given out the picture of the universe, and it said that the universe looks like a big egg, which was told by our ancestors in the ancient Indian texts guys. Okay, so it is a big egg, right, and our ancestors also told about the Andapinda Brahmanda, which means there are several of the smaller eggs which are the part of the bigger eggs, and the bigger eggs, the combination of several bigger eggs forms the universe. Okay guys, so the universe is made up of, the universe looks like an egg. Okay, the universe looks like an egg, right, and in that there are several super structures, eggs. Within them you are having again smaller eggs. Okay guys, so these smaller eggs are nothing but the galaxies. Okay guys, yeah. So now this is the universe guys. So the universe is a combination or congregation of billions of galaxies, right. See, we should not say combination. Here the spelling has been typed wrongly guys. It's a congregation, because when lots of numbers are there which are not countable, then we will be calling them as the congregations. So there are billions and billions of galaxies are present within the universe guys. That is the reason because of which we say that universe is a congregation of the billions of galaxies. Okay, then the size of the universe, actually the size of the universe is not known to anyone. Okay, with the present day technologies, with the present day optical instruments, the telescopes, the heavy and high ranged the telescopes and etc., right, we have measured or we have seen only up to 93 million light years guys. So let us suppose this is our universe, right, and we are present somewhere here, so we have seen only this much. Okay, so the observable universe is only 93 billion light years guys. And you know what is a light year, right? Light year is the distance traveled by the light in 1 year. And with what speed the light travels? it travels with the speeds of 3 lakh kilometers per second, guys, right. So, 3 lakh kilometer per second, okay, 3 lakh kilometer per second, right, into 60, which means hour, minute, into 60, hour, into 24, day, and into 365. So, if you make all these intos, you will be finding the distance which the light has traveled, guys. So, that is called as the 1 light year. So, till now the observable universe is estimated to be only 93 billion light years, guys. Okay, yeah. So, the age of our universe, generally whenever we talk about our age, we say it is around 14 billion years, guys, right. But it is 13.799 plus or minus 0.021 billion years. So, it will be coming to around just 14 billion years, guys. Okay, this is the age of our universe, right. As we told, the diameter is unknown, but the observable universe diameter is 8.8 into 10 to the power of 26 meters, guys. Okay, it is very, very huge, and this is only the observable, right, guys. It is not the unknown. Till now, the optical instruments what have been made by the humans can see only to the extent of this place, guys, 10 to the power of 10 to the power of 26 meters. Okay, then the mass. Okay, the mass is nothing but the ordinary matter within the universe, guys, right. The mass is estimated to be at least 10 to the power of 53 kilograms, kgs, guys. It's very, very huge, right. And the density, right, the density is per cubic meter or something, guys. Okay, when you are talking about this, it is in minus, guys, because lots of space is empty. Okay, lots of space is empty. There is a reason because of which it is coming in the minus grams, guys. And the average temperature here within the universe is just 2.7 Kelvin, guys. Okay, 2.7 Kelvin, because there are several places present in the universe which are devoid of light. There are several of the black holes present. There are the other areas where the light cannot penetrate because the light is emitted from some of the stars present in the universe. Okay, so lots of spaces are darker, guys. There is a reason because of which the average temperature is just 2.7 Kelvin. Okay, and the main contents of our universe are the baryonic matter. Okay, baryonic matters are nothing but the subatomic particles, which are also called as the hadrons. Okay, and that is called as the ordinary matter, guys. The baryonic or hadrons are nothing but the subatomic particles, and they constitute 4.9% of the total universe, and the dark matter consists of 26.8%, guys, right. The dark matter, okay, just we will be talking what the dark matter is, right. Actually, that quark gluon will be taken into the consideration of the dark matter, guys, and then the dark energy is 68.3%. This is the total main contents of our universe, guys, and the shape of our universe is flat egg, but it is flat with a variation or the 0.1 margin of error, guys, 0.4% margin of error. Okay, this is related to the statistics of our universe. Till now, what we know, guys. Okay, guys, this cannot be taken to be permanent. This is only an apparent, guys, because whatever the knowledge or whatever the instruments or whatever the calculations which we have made till now, with that we have found out this. Okay, in the near future, when the knowledge gained is more, when several other different methods come into existence, okay, then all these may get changed also. Okay, but for now, this is the reality which we have to take into consideration. Okay, so this is related to the universe, guys. Okay, yeah. Now the space. What is space? right. So, we all say that space, everything enters into the space, or the rockets go to the space, everything, right. But what is space, right? So, space is nothing but the universe devoid of Earth and its atmosphere. If this is the Earth and this is atmosphere, if you take out this, the totality is called as the space, guys. Okay. So, the space is the place within the universe other than Earth and its atmosphere. So, take out the Earth and its atmosphere from the universe, then that everything is called as the space, guys. Okay. Yeah. Now, the place of the Earth in the universe, where exactly in the universe the Earth is present, right? And to explain that, several of the theories have been put forward, guys. Okay. The first theory which was trying to explain the place of the Earth in the universe was called as the geocentric theory. Okay, guys, the geocentric theory. So, what are these geocentric theories? Yeah, the geocentric theory said that the Earth is present at the center. I have written the universe, guys, because for our understanding, guys. But at that time they were not knowing the universe also. Simply they thought that the Earth is present at the center. Just for our understanding, I have written the universe, guys, because we should know where exactly that what the geocentric theories are trying to tell. Okay. So, the geocentric theory says that the Earth is present at the center of the universe and it is stationary, it is not moving. And rest of all the celestial bodies, the stars, sun, etc., they are all moving around the Earth, guys. Okay. So, this is the geocentric theory's essence. Okay. So, what they said, the Earth is at the center and all the celestial bodies, okay, remaining all the celestial bodies are rotating around the Earth, guys. Okay. Because the Earth is stationary. And the main propounders of these theories are Aristotle. We know Aristotle, one of the greatest academician and scientist, but he has made a small mistake in the beginning, because see, at that time with their knowledge they were not having any optical instruments or look where exactly we are and all. Simply with their just thinking power they have come out with this theory, guys. So, we should appreciate their knowledge, but that whatever he told was wrong. Aristotle said that the Earth is at the center. Okay. Then came Ptolemy. Okay. Ptolemy also a great academician, right? He also said the same thing, that the Earth is in the center, guys. Okay. Then comes the great religious book called as the Bible, guys. It also told the same thing, that the Earth is stationary, right, and it is flat and not moving, guys. Okay. So, there are several of the people even now also who are believing that the Earth is flat. In spite of all the pictures, the satellite imageries and all, still some of the people are there in this world, right, who are believing that the Earth is flat, guys. Okay. So, the God only should save them for their ignorance, guys. Okay. So, these are the geocentric theories and their propounders. Okay. So, for the first time, Pythagoras and Philolaus, okay, Pythagoras and Philolaus for the first time stated that the Earth is not stationary, guys. Okay. They said that the Earth makes one rotation in every 24 hours. So, it is not stationary, it is rotating. Okay. So, these two persons stated that the Earth is not stationary and makes one rotation in every 24 hours, guys. This was told by Pythagoras and Philolaus. Okay. Then came the heliocentric theories. Heliocentric means sun-centric, guys. So, these theories says that the sun is at the center, sun is stationary and everything else is rotating around the sun, guys. So, this says that sun is at the center of the universe and it is stationary, right. And the first propounder of this theory was Aryabhatta, guys. Okay. Aryabhatta, the Indian astronaut and physicist. Okay. This is the person who first stated that the sun is at the center of the universe and it is stationary, guys. Okay. Then Aristarchus was the first person to propound that the earth revolves around the sun. The earth revolves around the stationary sun, guys. Okay. And that was propounded in 3rd century. Aristarchus first reported that the earth revolves around the sun, which is stationary, and that was in 3rd century. And in 16th century, the same thing was told by Nicholas Copernicus. And people forgot Aristarchus and they say that it was the Nicholas Copernicus who propounded that the earth revolves around the sun. But it was Aristarchus, guys. Aristarchus told this in 3rd century and Nicholas Copernicus said that in 16th century. But still we believe in Nicholas Copernicus. We forgot the Aristarchus, the real propounder of this statement, guys. And we know that later it was proved by Galileo, Kepler and Newton. Okay, so these are the people who have proved that the earth revolves around the sun, but the sun is stationary and the sun is at the center of the universe, guys, mind you. Though they have proved that the earth is going around the sun, right? They were the believers of the heliocentric theory only. And the heliocentric theory says that sun is at the center, it is stationary and everything else is moving around the sun. So they were the believers of heliocentric theories. And fortunately, they have proved that the earth is revolving around the sun, guys. Okay, this is related to the heliocentric theories. Yeah, guys. Next comes the galaxy, guys. Okay, actually till now what they were talking about, either the sun is at the center of the universe or the earth is at the center of the universe. Okay, till the late 19th century people were not knowing about the galaxy, guys. Okay, till the late 19th century the people were not knowing about the galaxy. Okay, so in the late 19th century William Herschel propounded that. Late 19th century, guys, this is the earliest 20th century. Okay, late 19th century William Herschel propounded that the sun is not at the center of the universe and it is a part and parcel of a bigger structure which is called as the galaxy. Okay, guys, so that was propounded in late 19th century. Right, and that was proved in 1920, guys. Right, and it was proven by his disciple along with himself, William Herschel only, guys. So in 1920 it was proved that the sun is not at the center of the universe, right, and it's not at the center, it is a part and parcel of a big superstructure which is called as the galaxy, guys. So what is galaxy? Galaxy is a huge congregation of stars, right, and the cosmic bodies, guys. Okay, so it is a huge congregation of stars. Other than stars, lots of other matter is also present in the galaxy, and that we will be calling it as the cosmic bodies, guys. And all these cosmic bodies and stars are held together by the force called as the cosmic gravity. Okay, so all the contents of the galaxy are held together by the force which is called as the cosmic gravity, guys. Right, generally our gravity, when we talk about the gravity of the earth, it is an attractive force, right, it will be attracting the matter towards itself, that is the gravity on the earth. But the cosmic gravity is the one which is the balancing force, guys. It is not attracting force. If it would have been an attracting force, right, all the matter, the cosmic bodies and the stars which are present within the cosmos, they might have attracted or they have come together and they have collided and there would not have been any galaxy in the universe. But here what is happening? There are several of the stars present, there are several of the other bodies, rocks, dust particles, ice particles, lots of things are present, right? along with the black holes, etc. But they are not attracting any other things. Okay. So, they are maintaining their distances. Though they are rotating, they are maintaining their distances, but they are not attracting. That is the reason because of which we are telling that the cosmic gravity is a balancing force, guys. It is not a attractive force. It is a balancing force. Right? Yeah. And we know that the name of our galaxy is Milky Way. This was our prelims question. Right? Or it is also called as Akash Ganga. This was also our prelims question. Right? And our galaxy is also called as the spiral nebula, guys. This has not been asked yet till now. So, the name of our galaxy is also called as the spiral nebula. Okay. And when it comes to the diameter of our galaxy, guys, right, again the galaxy also looks like an egg. Okay. And the diameter of our galaxy is 1 lakh light years. Okay. The diameter of our galaxy is 1 lakh light years. Okay, guys. And the thickness of our galaxy is 5,000 light years. The thickness is 5,000 light years, guys. Right. The diameter is 1 lakh light years and the thickness is 5,000 light years. And again it is a flat structure, guys. Okay. The universe is flat. Within that, all the galaxies which are present, they are also flat. Okay. This is related to our galaxy. Yeah. Look at the picture of our galaxy, guys. This is our galaxy or the Milky Way. Right. And this is only till to an extent of observable. Right. Our galaxies, this is our galaxy, guys. It is the part of our universe, right? And within this galaxy, right, the sun may be somewhere, like if this is called as the center of the galaxy, guys. Okay, if this is the center of the galaxy, right, the sun is present at a distance of 30,000 light years away from the center. Okay. So, the sun may be a small dot which is not visible in our galaxy, and we think that ourselves within that the sun is a small spot, right, and nearer to that sun the earth is much more smaller, right, and on the earth we are nowhere, guys, and we think that we are everything in this universe. Okay. This is the picture of our galaxy, guys. Yeah. So, what does the galaxy consist of? Okay, what does the galaxy consist of, guys? Right. And this was our prelims question. The galaxy consists of, number 1, the red giants. And the prelims question was, what are red giants? Okay, in our preliminary examination there was a question, and the question was, what are red giants? So, what are these red giants, guys? See, whenever a star is born, okay, guys, let us suppose a star is born, right? After the star is born, as the time passes, right, the hydrogen will be getting depleted, guys. Okay, and within 10 to 12 billion years, within 10 to 12 billion years, what happened? The hydrogen gets completely depleted, right? When the hydrogen gets depleted, right, the size might have been fully blown out, guys, and that is the reason because of which they are called as the red giants. Okay. So, the red giants are the hydrogen depleted stars, and that was our prelims answer, guys. And when the hydrogen of the red giant will be completely getting depleted out after 10 to 12 billion light years. Okay. Yeah. So, these are the red giants. Then what is the planetary nebula? We said the galaxy consists of red giants and planetary nebula, right? So, once the star attains the maximum size, okay, the red giant guys, when the hydrogen is getting depleted, slowly, the size will be going on bulging. And after it bulges to the maximum extent, what happens to the ball guys? Generally for our understanding, it will be bursting off or it explodes, right? After its maximum size of expansion, it explodes. Okay, so when the red giant explodes, the materials given out are known as the planetary nebula. Okay guys, so the planetary nebula is nothing but all the dust particles which are given out from the explosion of the red giant guys. Okay, yeah. Then what happened? Why we are calling it as the planetary nebula? Okay, why we are calling it as a planetary nebula guys? Because after the explosion, the particles will be moving in all the directions guys. Okay, they will be moving in all the directions. So then what happened? If any of the star is approaching, because this will be moving with higher speeds guys, the dust particles after the explosion, they will be moving in all the directions with higher speeds, right? So when they are moving in all the direction, if any of the star is approaching that dust particles, right? So the dust particles may get attracted to the star, right? And in the near future, they may become the planets of this star. Hence we are calling it as the planetary nebula. Okay, the planetary nebula is also called as the supernova. Okay, the planetary nebula is also called as the supernova guys. Okay, what if the star is not coming or any of the star is not approaching? Because all the stars are in motions guys. Okay, all the stars are rotating and revolving within the galaxy. So the dust particles have spread up. If nothing is coming nearby, so what happened? After their maximum expansion, the dust particles after they maximum expand, they will not be having any energy to expand now guys, right? So what happened? They will be falling back to the point of explosion guys. Okay, all the planetary nebula or the supernova will be falling back to the point of explosion. Okay, because it is not the gravity which is present in the universe guys. If it would have been the gravity, they would have fallen somewhere. But it is the space which is present in the universe, and that does not have anything else guys. So they are the balancing forces. So the expansion takes place and they fall back to the same position, right? And when all this matter fall back to the same position, okay, and when it is falling back, right, they will be trying to get contained into the minimal place guys, because the star size was this, born when it was born, it was this, right? It has become the red giant. Okay guys, so what happened after the explosion, right? It tries to fall back guys to attain the minimal position. Okay, so when it is trying to attain the minimal position, it may attain the size of, if this is x guys, 1/10 of x. So 1/10 of the original size, right? If the particles come closer and attain the size of 1/10 of the original size, right? Then it is called as the white dwarf. This was our prelims question, right? And not only this was our prelim question, this 1/10 of x is called as Chandrasekhar limit. Chandrasekhar limit guys. This was also our prelims question. When the star attains 1/10 of its original position, it is known as the Chandrasekhar limit. Okay guys, yeah. Then the white dwarf, just now I told. Okay guys, after attaining the 1/10 of the position, still it will be trying to get closer, guys. So when it is trying to get closer, right, the temperature and pressure are increased immensely. Okay, because they are trying to get into compact position, guys. Everything is trying to get compacted. So what happened when everything is getting compacted? If just you press your hands, guys, pressure is more, right, and the temperature increases. The same thing will be happening within the white dwarf. Okay, and then what happened? The white dwarf's materials which are present, right, the atoms which are present will be broken into the subatomic particles that are called as the hadrons or the baryons. Just now we have said that 0.44 some x% of the universe consists of the baryonic matter. Okay, guys. So that baryons are created by the breakdown of the subatomic breakdown of the atoms, right, after they are being compressed maximum. Okay, guys, after the stage of white dwarf, right. So after the white dwarf, everything will be getting compressed. So because of the temperature and pressure, right, the particles will be broken down, guys. So whenever we talk about the atom, right, the atom will be having one nucleus and the electrons, guys, the valency of electrons will be there, which are moving around the nucleus. Because there are lots of empty places, we are able to see each other, because air is also all made up of all the gases or the atoms, but the spaces between the valencies are more. That is the reason because of which we are able to see. But in the white dwarf, what is happening? Because of the increased temperature and pressure, the baryonics, what is happening? The matter, the place is completely lost, guys. So everything is broken into, the electrons will be broken, the protons will be broken, the nucleons will be broken, and everything will be falling back to small portion, guys. So there is no space. So this area will be completely consisting of the baryons without any space, guys. Okay, completely consisting of baryons without any place, and that we are calling it as the black hole. Okay, guys. So the area is full of matter without a small gap, guys, right. That is the reason because of what happened, whenever the light tries to travel, it is opaque, so we cannot see the light, and we are calling it as the black hole, guys. And the size of the black hole may be sometimes several times bigger than our galaxy also. Okay, guys. So these are the black holes, and sometimes they are the parts of the galaxies. Okay, so their size may vary from smaller to bigger. So they may be the part of our galaxy, or within the universe there are some black holes where our entire galaxy can be put into. That is the reason because of which we said that the dark matter is maximum, right. So the black hole consists of the totality of the matter only, guys. The baryons are the hadrons, right. So the matter which is present in the black hole together is called as quark gluon. Okay, quarks are nothing but the baryons or hadrons together, guys. They are also called as the quarks. So all the quarks are glued on together without any space. Hence the matter which is present in the black hole is called as the quark gluon. Okay, guys, this is related to the black hole, right. Next, the galaxy also consists of the binary stars. Okay, what are these stars, guys? The stars are self-luminous celestial bodies. They will be shining, they will be giving out the light. So stars are individual entities which are present in the galaxy, guys. But within the galaxy you are also having the binary stars, right. So two stars are together, present together, guys. and they will be moving around one another. They will be having same center point of point around which they will be moving over one another, guys. Okay, so that is the binary stars. Two stars are present together and they are rotating around each other around a same center point, guys. They are called as the binary stars. Then comes the neutron stars. Okay, so previously they said that neutron stars are the stars which are having more than 5 solar masses of size, guys. Okay, the stars which are of more than 5 solar masses should be called as the neutron stars. But now newly they are telling that the neutron star is the center of a collapsed star. Okay, neutron star is nothing but the center of the collapsed star, right, which was more than 15 to 25 solar masses. Okay, so the bigger star which was 15 to 25 times more than the solar, our sun, when it collapsed, guys, right, the center which is still bigger than the sun, guys, that is called as the neutron star. Okay, and there is one theory which says that the black holes will be formed only by the neutron stars. Okay, so black holes will be formed only by the neutron stars. Here now what is the black hole, guys? We said that the star will be expanding, blowing off, exploding, falling back to form the white dwarf and then the black hole. Okay, guys. So what they say? Only the neutron stars have the capacity to form the black hole. Okay. Other stars which are lesser than 5 solar masses will be remaining as the white dwarfs only. Okay. Again from the white dwarf, the star will be born, guys. Okay. So this is a continuous or cyclical process. So from again white dwarf, white giant. Okay, guys. Then the VIBGYOR, guys. Okay. So our sun is now present. It is VIBGYOR. This is the star sizes, guys. The colors, change of colors of a star. Okay. So some of the people are telling, some of the scientists, not people, they are telling that our sun is present the green giant. At present it is the green giant, guys. Okay, and some of the other scientists are negating and they are telling that it is an yellow dwarf. Okay, so our sun whose what is that, guys, age, right, how much is the age? 4.2 billion years, right? So at 4.2, some of the people are after 4 billion years, some of the people are telling that our sun may be the green giant or the yellow dwarf. Okay, then it becomes yellow giant. Okay, then orange dwarf, then orange giant, then red dwarf, then red giant, and then our sun will be exploding, guys. Clear? So this is related to the neutron stars, right? Yeah. Then comes the variable stars. Generally, when we look into the skies, we can see some of the stars which are twinkling, guys. Okay, the twinkling stars are called as the variable stars. And this was again our prelims question. And in the examination, they have asked, what are Cepheid variables? Okay, in the examination, the question was related to the stars, but they have asked, what are Cepheid variables? Cepheid variables are nothing but the variable stars or the twinkling stars. Okay, why they are called as the twinkling stars or the Cepheid variables? And mind you, guys, the sun of ours is also one of the Cepheid variable. Okay, because the energy emitted or coming out of the sun, guys, will be changing from time to time. It is not the same energy which is being emitted from the sun's surface. Sometimes it is more and sometimes it is less. Okay. So, when it is more, the glow will be more. When the energy emitted is less, then they will become dull. Okay. That is how they will be twinkling, guys, and they are called as the Cepheid variables. And just now I gave you the explanation for red giants. The hydrogen depleted stars are called as the red giants. Within 10 to 12 billion years of their birth, they will be becoming the red giants. Red giants finally bulge and burst out, liberating the dust particles called as the planetary nebula. Okay, guys. Yeah. So, after the explosion of the red giant, the dust moves with the maximum velocity, is expanding maximum, okay, into the space, and finally they return back to condense and tries to fit into the smaller of the sizes. And if any star attains 1/10 of its original size, that is the Chandrasekhar limit, it is known as the white dwarf, right. After the Chandrasekhar limit, the temperature and the pressure of the white dwarf will be increased tremendously, and thereby the atoms break down into subatomic particles, right, and become more denser. The densest matter is called as the quark gluon. Okay. Yeah. So, what is quark gluon? Quark gluon, there is no space between the subatomic particles, right. Therefore, the light cannot pass through it. So, the light gets absorbed and we are calling them as the black holes, right. Neutron stars, right. A neutron star is a collapsed core of a massive star, supergiant, guys, which is having a total mass between 10 to 25 solar masses. 15 to 25 I said, but it is 10 to 25, guys. Okay. And it is said that only they form the black holes, guys, right. Yeah. So, the stars with less than 5 solar masses will be remaining as the white dwarfs. Okay. Yeah. Now, recently this person, Schwarzschild, he has come out with some calculations, guys. Schwarzschild has come out with some calculation and said that any star based on its original size and the last size, guys. Okay. Any star which attains the Schwarzschild's limit, any stars that attains the Schwarzschild's limit will be transformed into a black hole. So, there are lots of calculations given by Schwarzschild, guys, and he said that any star which attains the Schwarzschild's radius, it will be called as the black hole. Okay. Yeah. So, the galaxy close to our galaxy, the Milky Way, is Andromeda Nebula, guys. Okay. This is related to the galaxy and the universe and the space, guys. Okay. So, we will be stopping for today here, guys.